There we go. So we said in an exponential function, y equal ax, a to the power x, we said a few things. A was a positive number not equal to 1. That was the conditions for exponential function. And we ended up with values y is greater than 0. Yeah, we ended up with values y is greater than 0. When we graphed it, we end up with the following graph. This following graph is important because if you notice, this is a function. We said it's a function that means every x value has only one y value. Yes? This particular graph has additional rules to it. The rules is every y value, if I take all the y values and all the x values, every line, whether I do it horizontal or vertical, will cross the graph in only one point. Yes? So every y value has only one x value. Every x value has only one y value. These special functions, we call them one-to-one function. Okay. One-to-one, that means every value has just one value, whether we're talking about x or y. And those values or those functions has a return way. Okay? Has a return way. And that return function is called inverse function. Yes, it's called inverse function. Logarithmic function is the inverse function of the exponential function. Imagine you go into some place where there is only one way to go to come back. That's the only one way to come back. Yes? Those will be specified as inverse functions because you only go one way this way or one way the other way. Okay. And the inverse function, let's go ahead and write it down, is a function of the form of y equal log, let's say base a of x. I'm going to go ahead and put a general form. Y equal log base a of x. If we have this function, what does that mean to us? In terms of exponential function, this means a to the power y equal x. Those two represent the same thing. Yes. Those two represent the same thing. What does that mean to me? Let's take an example. Maybe that example will illustrate it another way. Here we're taking a value, right? In this particular function, we're taking a value, we're raising it to some number to get another value. Yes? In this particular equation, we're saying this the log of this value is equal to that. So another way, what number do I raise a to get x? And according to this, you raise it to the 1. Yes? Let's take an example. Log base 2 of x. Oops. Let's make that 8 equal. The question is, if I will go ahead and try to transfer this equation to look like that, yes? The a is 2. So 2 raised over here, I don't know what that answer is just yet. 2 raised to what power equal 8? 2 raised to what power equal 8? So what would that answer be? Let's do it. 2 times 4 is 8. But 2 raised to the power means how many times will I multiply 2 by itself to get 8? 3 times. Yes? So this is 2 to the power 3. So therefore, the answer to this one would be simply 3. Yeah? Because 2 raised to the third power equal 8. Clear? Okay, let's take a look at these rules. We said, so this is just an example to explain what that is. Let's go ahead and put the rules down. When we did this, we said A must be greater than 0, not equal to 1. Yeah? Similarly here. A greater than 0, not equal to 1. Okay? We said X in this case is always what? Positive. Yes? So X is greater than 0. Same thing. X is greater than 0. Okay. The exponent can be any number from negative infinity to positive infinity. The value y can be any number from negative infinity to positive infinity. This is called the base of the exponent. This is the base of the logarithm. So log has bases, and its bases are any numbers greater than 0, not equal to 1. Yes. However, a very important base, 2 important bases we're going to talk about, and those are on your calculator. The first one is log. Log without any base means simply that's log base 10. If you don't see the base, then the base is 10, and we call that common log. That's a common log. Another log we're going to talk about is called, you see on the calculator you have the ln key. That is the same thing as log base e. Yes, ln is the same as log base e, and this is called natural log. Those 2 keys you see on your calculator all the time. Some calculator may have a log with a little square on the bottom. That means you can input any base you want. Okay? But generally speaking, log means log base 10. ln means log base e. Okay? And those are natural log. So now let's go ahead and take a look at some examples how you calculate bases or logs. Now let's take a look at the formula. Log base 3 of 9. Simple and easy questions. What is log base 3 of 9? Question, or what number 3 is raised to get 9? 2. The answer simply is 2. Yes? What is log base 3, say, of 1? 3 to the power what number equal 1? 0. Yes? What is log? Base 10 or log of 1. Don't need to write the base for that. Hmm? 0 again. Okay? So let's start writing some rules around. Any number other than 0 raised to the 0 power is always going to be 1. Yes? So let's go ahead and write these. So what does that mean? Means the log of any base of 1 equal 0. So if we have, as soon as I see log 1 of any possible base, yes, of the log, the answer is always 0. Yeah? Okay. Let's go ahead and take a look at log base 3 1/3. That is equal what? Any idea? Three raised to what number equal 1/3? 3 to the power 1 is equal 1. 3 to the power 3 is 27. Okay, let's change 1/3 to 3 to the power something. Okay? How do I do that? We're going to start with 1/3. This is exponential, correct? But I don't want this to be in the denominator. I want this to be on top, right? So what do I do with the exponent when I want it to be on top? Make it negative, yes? So this is the same thing as 3 to the power -1, correct? So now, 3 to the power what number? Give me 1/3. Yes? Okay, let's do one more. How about log base 3 1/27 -3. Yes? What is log base 3 of 3 to the power a? If it's 3 to the power 3, does that give me 3 to the power a? Okay, let me ask that question simple. Hopefully. 3 raised to what power? Give me 3 to the power a. Yes? 3 raised to the power a equal 3 raised to the power a. Does that make sense? So again, if I go log base 2 of 2 to the power 5, that would be what? 5. Because 2 raised to the 5th power equal 2 to the power 5. Yes? So rule number 2. Log is a of a to the x equal x. Yeah? If the base and the argument are the same, then the answer is simply the exponent. Yes? All right. Now let's do this. What's log by 3 of 3? One. Again, if the argument and the base are the same, the answer is always 1. So log base a of a equal 1. That applies to all log, whether it's a natural log or common log. Also apply to both of these. Let's see what else they have in there to explain. Let's go ahead and take a look at, now we know a little bit about how to calculate log. Let's go ahead and see if we can graph that equation. Yeah. And let's see how the graphs are going to look like. Let me leave those rules up here. Let's take a look at y equal log base 2 of x. Y equal log base 2 of x. To graph it, we need to take values for x, yes, and figure out the log base 2 of x. What does that equal to? So remember, one of the rules says we can only use positive values for x. So we cannot use negative values. We cannot use 0. Okay? So let's choose, based on what is given, I need to pick values I really know their answers. Yeah? So I'm going to get the first one, 1. If x is 1, then we know the log of any base of 1 equals simply 0. What values for x should I choose now to get an answer that I can plot? 2. Yes, based on the rules, if the base and the numbers are the same, the answer is 1. How about 4? And that will give me 2. How about below 1? We did some, didn't we? 1/4. Maybe we go with 1/2 first. Okay, so we can use 1/2. 1/2 gives me maybe what? -1. Yeah. 1/4 give me, say, -2. 1/8 give me -3, and so on. Yeah. So now when I come to graph it, at 1, I get a 0. At 2, we get a 1. At 4, we get 2. Now, below 1, between 0 and 1, between 0 and 1, all my values are negative. Yes? So let's do that. Halfway, 1/2 is 1. 1/2 again of that is another 1. You remember this 1/2 thing? Yes? And then half of this, I'll go down another one. Is it going to ever get to 0 over here? No. So y equals 0 is your vertical asymptote. Yes. And the graph goes like this. Remember, when we were doing 2 to the power x, what happened? We had the 1 here, right? Then we said every step forward, we double the value of y. And every step backward, we halve the value of y. So as I go from left to right, the values double all the time. So the graph looks like this. Yeah? But here we have the other way around. As I go from bottom on the y to top, what happened to the x values? They double. Yes. So here at 1, at 0 for the x, 1 for the x, we had 0 for the y. As I move one step on the y, I double the x. I move another step on the y. Now I double the 2, it becomes 4. If I move another step on the y, what do? I double the 4, it becomes 8, and so on. So notice those two graphs are with respect to the line y equal to x, those are symmetric to each other. Another way, if I were to fold this board on this line, these two graphs will be exactly on top of each other. Okay? So that's what we call basically inverse. I'm not going to be talking about inverse right now, but this is just an introduction. Okay. Now, in exponential function, we said this is 2 to the power x. To do 3 to the power x, what's going to happen? We're going to go above this line and below this line. Remember that? Well, log base 3 is going to happen the same time. But we're going to go below this line, behind that. 4, similar. Yes? And so on and so on and so on. So base, all natural log will look like this. All natural log graph will look like this. Now, this is the base natural log. So log base 2 of x. Nothing added, nothing subtracted. Now, I did say, inside the log, the x cannot be negative. That does not mean we cannot have log base 2 of negative x. Can I have that? Yes. Why? We could have x to be a negative number, yes? And a negative times negative will give me positive, so therefore it will be okay. How does the graph of this look like? Well, before, when we're talking about reflection of the graph, we said if we switch x by negative x, what's going to happen? The graph is going to reflect on the y-axis, yes? Reflecting it on the y-axis. So instead of it being on this side, it would just simply be what? On the other side. But yes, we can have log of negative x. in there to go ahead and work with this. Okay. Now, oops, that's not the eraser. That's the eraser. So one thing, I didn't put the rules up. So if we have log is a to the power x. Oh, I did that. Yeah, I did that. So let's put some rules up there. One more rule I want to add. That is a to the power log is a of x equal x. Yes? Okay. Stuff I want you to work with, and I want you to find solutions for. I'm not going to cover them right now, but I'm going to write the rules, and you're supposed to find proofs for that. Okay? Wherever you find the proof, that's fine, as long as you yourself understand what's going on. Rule number 1, log of any base of x times y equal log of the base a of x plus log base a of y. This is called the product rules of the log. So this is the first one. Division rule. Log base a of x over y equal log base a x minus log base a of y. Yes? That is rule number 2. And what is the third rule I said? Log base a of x to the power r equal r log base a of x. So these are 3 rules. Yeah? These are 3 rules. What I need you to do is, I need you to prove those are true. Using the fact that if y equal log base a of x, this means a to the power y equal x. Yes? This means a to the power y equal x. So this rule you can use. You can use any of these rules. Yeah? But you cannot use these rules themselves because you haven't proved them yet. After you have proven a rule, then you can use it to prove anything else you want. How do I prove a rule? First of all, you don't use numbers. Okay? You don't use numbers. So you need to look it up online. When you look up online, you say proof, not what is it equal to. You can go to the tutoring service, you can go anywhere, as long as you bring it written to the class on Friday. This coming Friday. Yes? So you got 2 days to determine the rules and get it, prove it. And every proof you get correct, you get 5 extra credit on test number 1. Okay. Now, those extra credit apply whether you repeated the test or not. Let's say in the future, you did good on test 2 and 3, and you said you want to repeat the test. And I said I can let you do that, right? Those extra credit apply to the new score you get. So even if you improved your test score, still up, and you have those extra credit will still be there, will be applied as well. So if your grade was, let's say, 50, you improved it to 70, yes? And then you have 15 here, plus 15, that will give you 85. Okay. Just in case you're wondering on those. So those will be applied as well. Okay. Okay, so this is the extra credit I want you to do for Friday. So now, let's go ahead and continue a little bit. And let's talk a little bit about natural law. We said natural log is the same thing as log base E. Yes. And the natural log have the same rules as the common logs we said base 10 or any other log. So what is ln of 1? Usually natural log is written as ln, that's on your calculator, yes? So now what is ln of 1? Zero. And still that rules apply, yes? Remember, log of 1, any base is equal to 0. Number 2, what's the ln of e to the power 7? Which rules on the left do I apply? What's 7? Why this rule? Yes? ln mean log base e in both, in here and in here, and therefore the answer would be simply the exponent. Yes? So what's ln of e? This is equal to 1. Yes? Okay, let's go back a little bit. A of log base A of x equal y. This means A to the power y equal x. Yes? So let's take a look at this one. A to the power log base A of x. Yeah? What does that equal to? We just said it's equal to x. Yes? How is that it's equal to x? Let's start with this. Let y equal log base A of x. Let y equal log base A of x. Yes? Let's see if we can prove it. I don't know. So what does that mean? That means A to the power y equal x. Yes? A to the power y equal x. Yes? So what is that? That's A to the power log base A of x. Yes? What is log base A of x? Log base A of x equal y. So that's A to the power y. That is equal yes? Did I use any numbers? That's how your proofs are going to be looking like. Don't want to use any number whatsoever, right? Don't want to tell me, well, if I do this and then I add them, I get the same thing. That only happens in once, yes? So this is something of how to prove things. So first I assume this to be some number, right? And based on the rules of exponential, based on the rules of logarithmic and exponential, what happened? We can say this is true, right? If this is true, then I change this to y, because that's what I called it, y, yes? And therefore, a to the power y is equal to x, and therefore, we prove this one. So I want you to do something like that to prove the product rules, the division rule, and the exponent rule. And then on Friday, we start doing something that applies to those rules. Okay? I think that's all I'm going to do today. I'll see you back here on Friday.